So let us look at the simulation of the Gauss law which I explained right now. So this is your Gaussian surface which is shown in the square. So at the center it is given as phi net, that is the total flux, which is given as 0. So phi top means the amount of flux which is coming out of the top surface, left surface, this is your right surface, and this is your bottom surface. So when you add all the flux, we'll be getting phi net, that is nothing but total flux. So right now it is 0 because there is no charge present within the Gaussian surface. So the net flux is 0. So now let us consider a charge of 2 nanocoulomb. If you look over here, a charge of 2 nanocoulomb is taken inside. So what is this charge doing? It is emitting electric field lines, and that electric field lines is captured by the surface. So now it is called as electric flux. Now if you are able to calculate the total electric flux, so you look over here, when you add phi top, there is 43.16 plus 31.49 plus 81.97 plus 69.33. So that gives you a value of 225.94. So the total flux which you have got is phi total which you have got is 225.94. So now you know the value of epsilon naught. So it is 8.854 into 10 to the power of minus 12 coulombs, right? So you need to capture, you need to find what is the amount of charge which is present within this Gaussian surface. So how do you calculate that? So from Gauss law you know that phi is equal to q divided by epsilon naught. So q is equal to 5 into epsilon naught. So you can make use of this equation. So what is phi? It is 225.94 into what is epsilon naught? 8.854 into 10 to the power of minus 12. So that would be 2 into approximately 2 into 10 to the power of minus 9 coulombs, that is 2 nano coulombs. So you got the value of charge which is enclosed within this. So this is a brilliant idea which is given by Gauss. So if I include another charge, let me consider another charge of 2 nanocoulombs. So look over here, I'm adding another charge of 2 nanocoulomb. So what is the total flux which is coming out? So it has increased. So the value is how much? 451.89. So if I want to calculate the charge, so I just need to multiply total flux, that is flux coming out of the top, left, right and bottom. If I add all the fluxes, the total flux is 451.89. So it is 451.89 into 8.854 into 10 to the power of minus 12 coulombs. So that would be equal to 4 nano coulomb per meter. So when you multiply this, we'll be getting 4 nano coulomb. So in the charge present within this Gaussian surface is 4 nano coulomb. So this is how we'll be able to calculate the charge enclosed within the Gaussian surface by making use of the Gauss statement, that is phi is equal to q by epsilon naught. So I think you have understood the concept clearly with this simulation. Thank you for watching the video.